Okay, guys. Welcome everyone to this open lecture. So today we have the pleasure to welcome Andrés A.Dejanon. Andrés is an architect working at Indisoluble. Indisoluble is a company from Barcelona. They do a very nice job in the field of museum and exhibition design, among other things. And I have always admired the bridge that they do between design and bridging stuff from paper to reality. And the thing is that they have their own workshop, so all the stuff that they develop at their office is also built at their facilities, which is like closing the loop somehow, no? And there are like some former students of this program who have been like practicing there at least like several years ago. And if you visit, I'm not sure if you're going to display this work, but if you visit Cosmo Caixa, which is a museum in the...
Yeah, I'm going to show you.
Okay. I go there a lot on Saturdays with my kids, okay? Yeah. There is like a sort of a brain, which I enjoy it a lot, and the kids also, okay? So I think that you're going to enjoy this lecture. We have been always like trying to get in contact with them, okay? And with the students of the program, it happened somehow. And thank you so much for accepting our invitation, Andrés.
Thank you for the invitation. Okay, so I'm going to present you a couple of not complete projects, but pieces of projects that we have developing in the studio. And at first, small presentation. We are a company, like you said, here in Barcelona, and we say that we are a fusion between design, technology, and content. Our studios focus on exhibition design, and we design from the beginning content, space, and fabrication, and technology. So we have a multidisciplinary team in our studio. We have architects, designers, engineers, content designers, and a workshop with different people that manage the workshop. We have in our facilities 2 CNC machines. We can fold the metal sheet. We don't have laser cut. We have 3D printing, small 3D printing. This is our studio here in Barcelona, in Poblenou. Okay. So I think we was talking some minutes ago that maybe we don't are too focused on computational design. We try to be updating tools like 3D modeling, 3D software, visualization, Unreal Engine, but we try to be effective, and sometimes the use of, let's say, for example, Grasshopper, that is most of the software that we use for design, computational, and fabrication, sometimes is more a handicap for certain people that model in Rhino. So it's like sometimes if you are faster modeling in Rhino than creating a code, even if the code is faster in the future, sometimes we have to change, not change parameters, but change the project. You know, for me, like a Grasshopper is like playing chess. You have to anticipate the movements, so rotations, movements, elevation, offset, all the geometrical operations. But in the exhibition design, sometimes you are designing inside this chess game, and the client came with a poker game. So you have to change everything, not just parameters, so change the whole story of these spaces. We use as software basically Rhino, Grasshopper, Unreal Engine, and it's most of our core. And since 1 year ago, we have 2 engineers specifically focused on artificial intelligence. So at the time, they are working on text and images, generation of images. We are trying to bring into the architecture team to help us to create kind of use of that artificial intelligence, for example, in creating some Python scripts, because I think one person at the studio can write Python code, but with this team, we try to explain how works Python inside Grasshopper, and maybe with artificial intelligence, they can help us to create some snippets or small codes to develop parts of the project, not the whole project, but improve our workflow, okay? So this is a kind of index of some projects that we have developed. There are some, this Live Hub I'm gonna show you is in Qatar, GPRC Dubai, Sparkrati a lot. We have been working in the CERN in Switzerland for exhibition. Black Box is an artificial intelligence box that is traveling around Spain. Now it's in Pamplona, I think. FIFA Museum, and some of these projects have been collaborating with other exhibition teams like Media Pro or around the world in local teams. Okay, so this is the first project I'm gonna show you. I'm not gonna show the whole project, but most focus on our use of some parametric or computational tools in order to solve some issues of this project. Maybe some very simple if you see, because I know Coda is very experimental. I use in the edge the use of tools. But for some clients, this was a project in Doha, in an underground place like this, was this Matterport. And they asked the Cornell University, asked for develop an exhibition about nutrition and climate change, and like a new different kind of topics, sustainability, nutrition, artificial intelligence. So we develop each of these spaces. And this was think to be a temporary exhibition, and now we are moving to a new building, and it's converting to a permanent or semi-permanent exhibition. So we are moving stuff, recreating some pieces that we did. So it was the first was here. We are moving to here to a new building. That is this building. So they give us the 3 floors of this small building. It's gonna be like a small museum. Yeah, so we create all the model from like this. We use a lot of Matterport, so create point clouds, and then we translate to a model. In this case, in Rhino, we clean all the meshes and use to have an accurate measurement of the spaces. So this is this is gonna be the first floor, the second floor, third floor. Okay, this is the axis of the exhibition right now. But what I want to see, this is going to be an upgrade of all the space. But what I want to see here is, for example, when we design spaces, we test very fast in our workshop. For example, this lamp was created, and 3D is a nice model, but when you in front of the reality, there are some issues about transportation, materials, and different kind of stuff. For example, this lamp was a very curvy aluminum stuff, but when we realized that the size is too big to transport on airplane, so we began to redesign this lamp very more easy with flat pieces. So we divide I don't know if you can see here, no, the mouse. Okay, we discretize the surface, and this is right now is modeling, and when we model our pieces and create details, at the same time we are making prototypes. So this prototype is from 3 years ago, and this is like 5 years ago. So we draw and prototype almost in real time to test for finishing, like angles of the material, tolerance of the materials. So we don't use like, I don't know, simulation tools, like in real buildings, I don't know, Caramba and Grasshopper and all this stuff. So our simulation tool is our workshop. So every time that we have some prototype, some furniture, something that we have to or create in 3D, we immediately translate this to the workshop and then create a prototype so we can validate if the option that we are doing is good, the material is good, or the size of the product is good. At the same time, we use maybe optimization, like for the only tool that we use for optimization, let's say, is OpenNest to create nesting tools. But at the same time, it's optimized in a certain way, because when you use OpenNest, most of the time it's optimized for the don't waste material. But sometimes we prefer waste a little material, but not waste time. Okay? So this is for another project. So this is a more or less a basic nesting. When they put the pieces, I don't know, the A1 is in that corner, but the A2 is in this corner, B2, B3, B4, whatever. So we don't like that the people at the workshop wasting time looking for the pieces. We don't have time to produce all the pieces and then arrange the pieces and then assemble the pieces. So we prefer waste a little material, but put all the pieces that as soon as they came out of the machine, they began to assemble that pieces. So it's a kind of balance between time and materials. Okay, this is another images that there are render of previews of the idea of this room about sustainability. We also developed the technical stuff, screens, interactive installations, and that's another key part of have the workshop at the studio, because sometimes you think about I don't know, a lab or something, or a table with a screen, but you don't think in the tolerance of cables, or if you create like the brain that I'm going to show you in a minute. You design the whole place, but you don't think in that maybe there have to be some trafos or batteries in order to don't have latency in the data that you transmit from this table to some computer or to other table. So all that stuff creates another layer of complexity that sometimes is hard to work without a prototype a real prototype. It's hard to simulate that kind of problems in a digital environment. And yeah, this was let's say, the most digital or computational digital. Like, there is very simple waffle of OSB that sometimes you think that for us as an architect there are some solutions that for us is like stupid, because you use a lot and you have seen a lot, like a waffle or Voronoi and all this stuff, and you sometimes dismiss that because, okay, this is so boring, I have made this thousands of times. But sometimes the client came with the idea, I saw this, I want to do this. So because we work with content, we cannot be so experimental as we wanted. So sometimes we try to create, introduce computational ideas or complex geometries to solve some problems, but sometimes it's hard. And sometimes these basic solutions are very fixed or very related with the content. In this area of the exhibition was the nutrition area. So it was a calm area with all the rest of the area are very metal, light, artificial intelligence, like very futuristic. So with this simple tool, we solve the content, the envelope, and the structure for the screens. And this table was the center hub of all the computers for I cannot move the mouse. Okay, for the interactive situations on the screen, this was a simple model as we work in the studio. We try to be as simple as possible with our files. Try to create and generate notations, very basic notations, in order that the people at the workshop open these files and they don't use 3D. So our people are in our workshop, most of them are very comfortable with 2D drawings. But we tried not to translate all this information into plans and all the stuff, but try to capture the information as soon as we have the model with simple notations. And that's our way of work with the engrave and all this stuff. It's easy to put in place. People who work also, so this piece of part of the exhibition we put together in our workshop. So everything that, even if the scale is huge, we try to test it in the workshop to see times of assembly. And generally in these fairs, the time is very rough. So we parametricize the times and see, okay, this is easy to assembly, or we need to simplify the way of assembly this. Instead of make a lot of waffles or slabs in horizontal direction that is more difficult to put together, can we replace, for example, with some aluminum or another kind of structure that help us to put this together without losing the whole concept and the geometry that we created. But this is one of the advantages that we have in Indissoluble, that we can create and produce everything that we do in our workshop. So we don't depend on the other companies. Sometimes we use a laser penta or some local companies to help us to arrive on time, but basically we try to do all at our workshop. Okay, this is the tables. Okay, this is another project that you can see at the Cosmo Caixa is the name. So it's a brain. It was a brain with different kind of interactivities at the beginning. Now it's more simple exhibition. But the first was inside a talking brain exhibition. It was to understand how the brain works. So this was created again from the beginning was a point cloud of a brain, and then was created to mesh, and from the meshes was translated to surfaces. At that time, it doesn't exist Eevee. That was be very helpful. I know you know Eevee, the plugin to unroll meshes. So this was made without the plugin, but we don't have any troubles using a lot of plugins, but that have some problems also in the workflow of the studio. I'm going to explain you later why. So we decided from this, this was created with aluminum structure, opal translucent white, the opal sheets, and this magenta, how do you say these locks of the tubes was created in 3D printing. Okay, this project is it's quite old. So at the time was I was my first approach to Indissoluble. I was working in another company, but sometimes I do a kind of collaboration in deploying Grasshopper and computational design for solve problems. And this was my first approach to Indissoluble, and all these logs was created in 3D printing. So, but at that time was not like La Máquina and all the stuff, so they decided to buy 24 3D printing machines, a small 3D printing machine, and it was like, I don't know, like 3 weeks without stop producing all these logs to create the main structure of the brain. So this create a lot of different files. Every file is a 3D printing to create to separate the modules and send to the 3D printing machines. Also, we tested in the studio the aluminum, and was tested the interactive solutions. So again, when we have to create different installations, we have to take into account a lot of issues that maybe as an architect we are not accustomed to, like electricity, latencies, mm, different kind of thickness of cables that is very small, but 1 millimeter when you create something, okay, this cable, it doesn't pass. So we have to reproduce it or rethink the whole strategy of our designs. This was the interior of without the skin, interior skin. And this is the final prototype. Okay, so in the interior is a debond material, it's a triangulation. We use a lot of triangles all the time because I think it's the easy way to rationalize geometry of this kind of geometry, and it's faster to produce. And sometimes in these projects, time is very accurate. So because you have to, it's like design a stand. No? You have an opening. You cannot say, okay, maybe tomorrow we finish, and today, let's say, it's not quite perfect, but tomorrow we finish. If you do a stand, have to be that day. If you do an opening of an exhibition, have to be that day. So if you go to the Caixa Forum, you can see this brain, and this was another part. I think is also there. It was the intro of the exhibition. It was also another brain with some lights. This is our studio. It was Talking Brains. I think now it's just in the Cosmocaixa, just this brain of metal and the other one. The rest of the exhibition was temporary. This is a simple script. And another way that we use computational design for a private client. I cannot show more images. But since some time and now, we use for the beginning of the project, not to generate the whole project, but to generate ideas of how the space could be. In this case, it was a kind of plaza surrounded by the metal sheets, and the idea of the content group was create a kind of like a rock simulation. But as an architect, we say, okay, we can simulate rock with fiberglass, but it's a little bit like, I don't know, fallero. I don't know how you say fallero in English, but it's like a Disney, like a fake. So let's try to make something more geometrical that you can read like a rock or kind of rock without to represent that a rock like a real rock and with colors and all this stuff. So we began to create computational design to divide these walls in these small plates of metal. And when we began to do this, I don't know if it is another one. No, yes. The engineers of the studio say us, okay, you have to take care of the projectors of images, because if you broke too much the surface, the idea was to project in all this surface a story, different kind of stories. So if you broke a lot of these plates too much, it's too much grainy, you are going to lose the images. You're going to see more the geometry than the images. But if you have big panels, the projector is going to lose in the limits of the panel. So with this algorithm, in this case, we use to create a minimum and a maximum of this panel. So to create a kind of relation between content and geometry. And in this project was 1.5 years ago. And we began to work with a partner in, I think in Dubai, that has no any clue about Rhino or 3D modeling. So we decided to begin to use a Spickle. That I think maybe you already know that tool, but it was very helpful to integrate into the process to talk with people who are not related to Rhino. And it's very efficient in order, because as I don't know if you know Luis Fraguada, he said when we talk about speckle that is about interchange of data instead of formats. And it's like that. Because sometimes you have to say, okay, send me the 3D file, send me the Rhino. The Rhino, the size is 1.5 giga. And send it, you cannot open. This in Move It is very hard. So we decided to introduce with this project to collaborate with other companies, Speckle, in order to move a model fast and say comments, you can comment the model. So it's another kind of digital tool or computational tool that we introduce in our workflow in order to be efficient in the develop of the projects. This was the same. Another, they changed, in this case, this was helpful because they changed the location of the exhibition. So sometimes the grasshopper is not very useful because we change everything. In this case, was very useful because we changed the geometry. The location of the project was changed. So we already have this tool to accelerate our process instead of modeling a complex structure from zero. Another use that we create or use from digital tools, and was saying like if you see this, you can recognize a Voronoi structure, is to, in competitions, sometimes create the concept from the beginning, and from that concept, extrapolate to different objects in the space. In this case, was a museum in Estonia for a natural history museum. It was a competition. So the content team came with the idea of the typical idea of cellular. The life came from a cell. So they want to draw like cells with a very handy way. So we say, okay, let's be faster. We don't have time. Translate it with the most closest geometrical pattern to that is the Voronoi. So we began to think in you see the areas of, my mouse is not moving, okay. Areas of exhibitions, areas of where the people go, with some regulations of the Estonian museum that they sent us in the brief, the minimum distance between exhibitors or tables. So we introduced that from the beginning in this algorithm, and from this, we began to create the whole experience of the museum. So it's faster for us to create some experience introducing these tools. Even we don't use from the beginning to the end. As I told you, we are not a very focused company on computation. We use computation when we need it, and sometimes for very small part of the project. But with this, okay, this is solve the space. We need to recreate all the models and all the exhibition inside the grasshopper. Maybe not. Okay, so maybe we stop in some point and translate it to model in Rhino because it's faster. So because people who came to the studio, most of them doesn't know grasshopper. So training people in grasshopper at the same time that you are working is hard. So maybe you can explain some stuff, and if you can time to work in your house, it's okay. But sometimes it's too expensive for us to training people to learn in the middle of a project the tool. So we decided to, okay, you are good in grasshopper, do the algorithm. If you are more comfortable modeling and you are fast, because that's important, be fast, just go to modeling like in the rough way without the use of an algorithm parametric design. Even if for me it's kind of computation you are using, no? It's like today artificial intelligence could be a computational tool or no, I don't know. You know, it's like for architects, computational is parametric design, algorithmic design. But for other people, it's like if you are using a computer, it's a computational tool. It's a very basic sentence, but okay. So we decided to use that and stop at some point, and from that algorithm, decide to recreate the whole model and the different areas of the model of the exhibition. Create different areas that was mandatory at this museum was mandatory, was a main area for the main exhibition, and was mandatory to create an area for childs. So we decided to use the same logic of Voronoi in all the pieces of the museum, and use it in the area of childs, create some furniture like lamps, like these green tables that also came from that idea of Voronoi. And in this moment, all these pieces are okay. Stop. Let's go to model, because we also work in the same time with the visualization. So we use Unreal Engine or Twinmotion. Now we are beginning to use D5 render. But all the architects have 2-3 screens, and you have to make, at the same time that you are modeling, you have to produce images, and you have to send the images to the client all the time, or to Roberto, who is the CEO of the company. So sometimes it's, okay, stop doing the grasshoppers if you are stuck, model, create an image, send it, validate it, and so on. So we can change this like 20 times. Okay, and this is another project that is in the Olot. It's the Spy Crater. It's a space focused on volcanoes. And I was not here at the moment, but I show this project because when a lot of time when we began to do something, and we began in a rush and we don't have ideas, it's like the reference. Use the table of Spy Crater. Okay, open the file, copy the file. Sometimes it doesn't fit with the space, so began to scale in 2D or make some crap stuff. So I decided to, okay, if we're gonna use this, let's create an algorithm of that table that we are gonna use a lot, but without be the same table, try to create an algorithm that to generate, I don't know, thousands of tables with a couple of parameters. This case is a radius, a point that moves from the corner to the evaluate curve, 2 evaluate curves, I think, 2 radius. And with these 4 components, we can create thousands of tables, and we can adjust that tables to different kind of screens that we use a lot of technology now, different kind of touch screens and LED technology. So I decided to create this as an algorithm that everybody can use at the studio if they need to create a table without to think from the rough and invented the wheel. If we or the studio design a nice table that work well with content creations, and it's good for handicapped people and all this stuff, okay, let's try to create an algorithm that generate that table without being the same. So moving small and without very complex algorithm. So you can open, you have 4 sliders, move this, it's okay for you, okay. So this is a tool that we have generated the last couple of months. And the same are we doing with this, because we use a lot of triangles. With Eve and all the stuff, I'm taking some old projects and creating some algorithms that help people to are not accustomed to use Grasshopper or parametric design. With the less possible interaction with the script, create different geometries or different solutions that we use for when we use some auto-referential projects. So we are trying to do this now. This was for a stand from Telefonica, like from, I don't know, 10 years ago. I was not there. And okay. And you told me to show another thing that when I arrived to Indisoluble was a not very organizing infrastructure with basic stuff like files, because sometimes every people who work have his own workflow. So I put the names like that. I have noticed a lot of people who model in Rhino that they model a piece here. I want to test it another stuff. I put here, I put here, I put here. So when we try to work together with a work session, all this stuff, or we are doing an Unreal putting a lot of information inside a model, began to appear a lot of noise. So we decided to create a kind of very basic workflow of our work that we already that how to manage the Grasshopper files. So when I told you that we use plugins without thinking too much about the consequences of use a plugin inside a script, 6 times later you open that and the script, the plugin, it doesn't have installed in that. Well, now Rhino told you you don't have this plugin, but okay, go to that. So in some plugins doesn't have the connection in the package manager, so we have to create like a workflow, even if it's stupid, but please write down in a panel component which plugin are you using in this script. Also avoid spaghettis, and if you work, I don't know, like I think everybody who uses Grasshopper create at the beginning a mess, no, because you are thinking at the same time you are designing. We always rewrite, if you can say that, the script in order to put, okay, let's put all in the most clean way that every people who open that in a couple of minutes can understand how that works. So we create all the workflow that we have in Indissoluble is based on 2 routes. One is like we have always 2 models. Like one model is at the end of the project. We have always 2 Rhino models. One Rhino model go to the workshop, or is a model for fabrication where you have the nest, measurements, and always in millimeters. And we have another route that is centimeters. That route go to the visualization team. Okay, so always we have to duplicate or not duplicate. We work a lot with workflow or the work session, but at the end we have two models organized in the same way. The model who go to the workshop and the model go to the visualization team. So with these kind of strategies, we can solve some miscommunication between the designer and the workshop, because sometimes you send a file or to produce and they say, okay, the layer, whatever, and ask to the people who is developing at that time, is an architect developing the visualization. Say, no, for me that is the B3 layer, and the other guy, no, I'm talking the C3 layer, but it's the same. So we have a lot of problems some time ago. So we decided like create a workflow and separate these, or like work together, but 2 models in parallel. At the end of the production, one for that was for create a. So yeah, this is like inside a workflow of the company. Please we don't used to, instead of copy 1,000 times, copy the layer, duplicate layer. Another problem is people erase curves from Grasshopper, so please put in the first point, curve, surface, whatever, inside the Grasshopper. Don't leave like, okay, this is connected with a curve in that file that nobody knows. So always try to integrate the whole information into the script. So we are trying to do this from 2 years until now with results more or less quite good. Yeah, I think it's more or less what I wanted to show you, and leave the space to ask some questions, because you told me that at 3. Yeah? Okay.
Thank you so much, Andres. I think that I was like asking to him to show the guts of the company, and I think that you have like gone like beyond the expectations. So I don't know if you have like any questions, because like we have to be like quite punctual, like leaving the theater at 3. It's like we have like 2 minutes. Okay, so a couple of questions if you have it, or if you don't have it, it's gonna be me. Like okay. So I think that in most of the projects you have said that at the end, like you are like with the rush of the project, you like somehow like solve the design, solve the fabrication well, like of course with all the previous experience and the previous projects that you have like developed at the company, which is like a super like interesting ground base, no? Like a ground to grow the projects on top of this. But I don't think like if you should like balance in your company what is like computational design, engineering and fabrication, assembly, like testing the prototypes, and finally like doing the assembly, and doing also like all the, I don't know, like the commercial action to get like new projects and all this stuff. How would you like would you weight these like 4 or 5 like different areas in your company?
So we have the we have the architects are like use some computational design, but I think in percentage could be 40-30%. The rest of that is basically modeling. We have when we have interviews with people, we ask if you know Rhino, but it's not like you know Rhino. If you are fast modeling in Rhino, it's like when you go to a 3D render company, they ask you, you know 3D Max? Yeah, I know 3D Max. Okay, do this model this skyscraper in 2 days. No, I need 1 month. Okay, it doesn't work for us. So it's same for us with Rhino. So it's like 30%. Engineer is more focused on the installation part of the interactivity. We don't have engineers like construction engineers. So it's like architects and builders. We don't have an engineer in-house. So we test it, we validate it, and we produce it. But we don't have some people who say, okay, this is too heavy, too low, or it's more intuition and experience that we use to solve the problems. And the company have 25 years, so our boss Roberto has a lot of knowledge about that. And you ask him, this is not gonna work because the projector is too heavy, so change this D1 for I don't know, OSB of 12 millimeters or something like that. Yeah.
Yeah, I think that we like at least this is what happens at our office. That at the beginning, you spend like some time like talking with the workshop, with the manufacturers, and also like calibrating your design. Like calibrating the labeling of the pieces.
Yeah.
Or I don't know, like what you have explained, no? About how all the pieces come out of the machine. So that you can start like pre-assembling or manipulating, like modifying these pieces already, no?
And sometimes there was a shocking, at least for me at the beginning, was a little bit shocking because people who work in the workshop, they have like their routines. So I was sending these nestings, optimizing with materials and engrave and all this stuff. They said, no, we are not doing engrave. We put a tape with the number because it's faster. Okay, but when you lose the tape, you have to looking for that piece. We are not gonna lose the tape. So sometimes it's hard to fight against some routines that they have in order to be faster. Because even if we have 2 CNCs and it's not okay. It's faster to put a tape and write than the time that they engrave, but it's better to put engrave in the pieces. But sometimes it's hard to balance these 2 words of the people who have some ideas of how they work, and the idea that you have that as an architect, and you understand that is better, and the system is do it for that. So, but sometimes you have to balance that situations. But I know I think we are fast producing and testing all the stuff that we do. And we have a lot of nice or very fast communication, straightforward communication between workflow and the architects team. Yeah.
One last question from me. It's the last one, and then you go. What came first, the egg or the chicken? Like, what came first in your company, designing or doing like fabrication and prototyping, or the 2 things?
No, designing, because
you started buying a computer, and then you buy the CNC.
I think that the main the main worry about every project that we do is the user experience. Okay. Is the basic of everything is the user experience. So we began to always design, and when we have something that, because at the beginning of some project you can do crazy stuff, you know? Crazy, I mean like, I don't know, for example, a canopy like you do here in the, as a pavilion, that you, as an architect, say, okay, this is perfect for this space. And they say, okay, no, the client say, okay, this is not good because in this part it's gonna be a kid and this screw is dangerous, please change or whatever.
Yeah.
So that, so you have to change the idea. So first is the design, and in the middle of the process, when you more or less have the idea modeling and you say, okay, this is gonna be the, more or less the path that the project is gonna be, we jump to the fabrication.
Okay. Arvin, yeah.
Usually projects are very fast tracked. So structurally, how do you check it? So when project brain, so you did it with aluminum sheets. So structurally, how do you check it?
Creating a one scale prototype.
Okay, just a prototype.
Yeah.
So you check it with Canva,
Yeah.
prototype, and then
Yeah. Our tool for checking structurally everything that we do is the workshop. So we don't have an engineer that say, okay, this is gonna be heavy. This is no. We create a prototype of. In the case of the brain, the beginning was the half of the brain. So you check it. Okay, it's correct. Let's do it. Yeah.
One last.
In a lot of the projects, you have been linking projectors and a lot of lines and visual immersion.
Yeah.
So what are the things you consider while designing, keeping the experience in mind? Like collaborating with projector teams, how do you get it out?
So in the studio we have 3 engineers or 3 digital artists focus on that part of, let's say, engineering, and we also it's a kind of collaborative work. So every time that you are designing, you are talking with all the parts of the process. You talk with the workshop. You talk with the guy from content who say, okay, this is. We are talking. I don't know, to say something. We are wanting to create something warm, and you are putting in your design metal and translucency. That is not warm. So, okay, you talk with that. In the part, we talk with this engineer, and they tell us, okay, what do you want to do? You want to put a screen, touch screens. What kind of screens? 55 inches, 65, whatever. I have to learn a lot of that because I didn't know anything about screens. For me, all the screens, okay, I know these inches, but there are different frames to put that. So you talk with that guys. One of them have like, I don't know, 15 years in the company. They have a lot of experience. And you talk with them all the time that you are designing. You have an idea. You say, okay, this is correct. This is good for you. I'm going to put the computer here. And I don't know, the sensor there and the projector there, and the guy tell, okay, this is too far because from here to here is going to be latency. We are going to lose that signal with this distance, so please change the design. So we are arranging the design and changes according to all these inputs through the pattern. At the same time, we are designing. Yeah.
Yeah.
So I was intrigued by how you showed like different tables
Yeah.
possibilities. So when it comes to computational design, there's always this thought I have in my mind where we do like these complex algorithms for basically designs that are used once, or something like a super customized solution that might be super interesting to reuse, for example. But then it never gets reused at the same, like in the same way.
Yeah.
So I was thinking if the firm did thought in one moment of just I don't know, just trying to implement this algorithm that you've done maybe on the table, or another one you have there, to like something more efficient, right? To make like design super quick and to be as able as like to have this opening of forms or.
Yeah, we have like the table that I show you. We have like a small, let's call snippets of code, in order to solve some issues that we confront every time when we design a project, even when designers are different. But for example, envelope with some holes that we have randomly create. So we have we create a very small grasshopper script that create random holes into a metal sheet and can produce very small snippets like that. But because every project is different and changes, sometimes when we began to use, or even in the past when I was using Grasshopper more intensively, at the end it's like you are modeling in Grasshopper. You are not creating something. You are being faster and can change some parameters, but it's like modeling Grasshopper. You are not creating kind of different kind of solutions for the same thing. So sometimes you did, but sometimes at the end you say, okay, I did this facade. Is this facade? I'm modeling in Grasshopper. I can move this, but at the end you don't move because you have a lot of parameters that is fixed. And then I was thinking sometimes, okay, if I was doing in Rhino and repeat that, it was faster or not, you know, because it's like that. So we decided to create this not for the whole project, but snippets. To okay, you want to do I don't know circle packing to create holes in a double curvature. Okay, we have this script. Take it, you put your surface, especially with people who doesn't know Grasshopper.
Like your own clusters.
Yeah. So special clusters, and we put. You can apply for this, and we have like a small battery of tools, but yeah, we are trying to developing for that kind of stuff. Yeah.
Okay, guys, we have to leave the room. It was like switching on the lights like in a disco. So, Andres, thank you so much.
No, thank you for inviting me.